In integration, we know that if you have a coefficient or constant with f of x and you integrate them, then it is same as taking the constant out and integrating a function and then later just multiplying that to it directly. So if I do that same stuff here, then what will happen is, by the way, this is, yeah, so this, by the way, 4x cube, this is e raised to minus x. So this minus, by the way, I have to show you that this is multiplication. Yeah, I also have it, yeah, okay, this is a derivation. Same stuff can happen in derivation too. So what happens here is, wait a second. I did that here too, I guess, x cube stuff. Okay, so what I can do here is, I can just take, this 4 is all, by the way, this 4 and this is minus 1, by the way, I have to tell you, minus x equal to x into minus 1, which I told you already. Because nothing is there, means 1 is there. It is one time of itself, right? It is one time of itself. Or else it would have been 0, nothing. It is one time of itself. So, this minus and 4 can come to this side because they are constants. And constants can be taken out and you can integrate a function and just multiply it later on. So, let's do this. Why not? Minus x raised to 4, e raised to minus x. This comes here, minus. By the way, minus into this minus will be plus, okay? Minus into minus is plus. Have fun. So, this is a plus. This is 4. 4 goes out. Integration. X raised to 3, e raised to minus x. Now, I think you must remember that we did this earlier. X. This is minus x raised to 3, I guess. Wait a second. What? Okay, yeah. We did this actually, x into f of x. And this is x square, wait a second, where it is? This is x square into f of x, right? We solved for x, integration x f of x, and this is x square f of x. And, wait a second, let me just show you, by the way. I should have written this, x into f of x. So, x and our f of x is x square into e raised to minus x. X square, wait a second, integration x into x square to e raised to minus x. Now, x, by the way, did I tell you? Yeah, a raised to m into a raised to n. Bases are same, variables are same, only indices are different. So, we are multiplying them, so we are adding them because this shows how many times multiplied itself, and they both show same thing, so they increase, right? Increment, adding, okay? So now here this is x raised to 1, nothing means 1 is there because I told you anything raised to 1 is itself. Wait a second, where did I say that? Wait a second, x raised to, okay, x raised to 1 equal to itself, right? Multiply one time, it is itself, okay? X raised to 1 equal to itself, so x equal to x raised to 1, right? I told you. So now what happens is, x raised to 1 into x raised to 2, by this formula, I have to just take the common base and add the indices. So take this x common, add indices 2 plus 1 equal to 3, e raised to minus x. So this is integration x cube, e raised to minus x. And does it look same? Integration x cube, e raised to minus x. So let's just put it, isn't it? Minus x raised to 4, e raised to minus x, plus 4, then 4 bracket, and we just multiply it to this, minus x cube, e raised to x, to minus x, minus 3x square, e raised to minus x, 3x square, e raised to minus x, and minus 6 x e raised to minus x, minus 6 e raised to minus x. Right, so now what happens is, this would multiply to everything in the brackets, okay? Every term in the brackets. Multiply joins terms, okay? You have to understand.